let us look at the next criteria, which is Mohr Columb criteria. What this says is, it says basically that the shear stress at any plane should be, shear stress in any plane must be lesser than or equal to the cohesive friction or the wet friction or the gluing strength of the planes, okay, minus the normal stress in that plane times coefficient of friction mu. Okay. That is, what this says is, if a block is moving on a surface, you have frictional forces coming in, which depends upon the normal stress on that surface, right, between the block and the surface. That normal stress is sigma n, and the shear stress that resists this motion is tau of n. Okay. So, the resistance to this shear stress depends upon the dry friction between the surfaces, which will give me a resistive force of sigma n times the coefficient of friction mu, plus a wet friction term which is C, which is like if I glue those surfaces, there will be glue strength, right, which will resist irrespective of whether there is a compressive normal stress or tensile normal stress. On the other hand, if I add a tensile normal stress which is positive, the glue strength reduces. That is what this equation tells you. Okay. Now, let us interpret this equation in terms of the Mohr circle. In terms of the Mohr circle, I have tau of n, this axis represents sigma of n. Okay. So, in this Mohr circle axis, what this tells you is the relationship between tau of n and sigma of n is given by C minus tan phi or coefficient of friction times the normal stress. Okay. So, basically if it has a tensile stress, the shear stress goes to 0 at a particular point. Okay. So, basically I have a line I have this line, do not have anything beyond that, this is a point, this point is given by C by mu, okay. That is a limiting tensile strength. Note, we are plotting the tensile normal stress along this axis, this is positive normal stress, and this side represents compressive stresses. Normal stress, this is tensile normal stress, this is tensile normal stress and that side is compressive normal stress. Okay. So, if the tensile normal stress exceeds a particular value, it will fail, but whatever be the compressive normal stress, if it is a hydrostatic state of stress, it will never fail. That is what this theory tells us. Okay. And if you draw a Mohr circle which is contained within these two failure envelopes, if a circle is, if the Mohr circle is like this, it will not fail. The Mohr circle is like this, it is on the verge of failure. The Mohr circle is like that, is on the verge of failure. A Mohr circle which does this is not possible. Okay. That Mohr circle is not possible because it cuts the failure envelope. So, such a stress state is not possible. Okay. So, this blue lines represents the failure envelope for Mohr Columb criteria. Note, till now we have been writing the criteria in terms of the principal values or the principal invariance, but Mohr Columb criteria can be written in terms of the principal invariance, but it is a complicated expression. For this course we will not do that, whereas we leave it at the intuitive level wherein we write it in terms of the Mohr circle diagram. Okay. Where you have to understand that this tau of n is the shear stress in any plane, is the shear stress in any plane, and this is the corresponding normal stress in the plane on which shear stress is computed. Okay. So, it is possible that there exist planes where there are 0 shear stress, but it is not possible to have planes where the shear stress exists, but there is no normal stress at all. Okay.